Good evening, everybody. This is Dr. Renault, and I'm here to go through a quick assembly of the WHDTS 4-digit digital clock kit number 1765 from Amazon. Um, on my work desk, what you need to do first thing is clear off a nice workspace. You need a lot of light, you need a flat surface, and you need a surface where you possibly could get a blob of hot solder and potentially don't do this on your mom's good dining room table. Do this somewhere where you are safe, a work surface somewhere. Maybe you've got a kitchen counter in the garage or something where you could do this. A lot of light. You need some air circulation, as this will create a few fumes. And this does get hot, so you want to make sure that you don't burn the house down. So you have your kit with the soldering iron, you have your kit with the clock in it, you have your snips, and you also have a roll of really fine solder, and we'll talk about that in just a moment. So I have those laid out on my workbench. Let's now take a look at the next. Here we go. So I opened up my kit and I have to assemble my soldering iron stand. That's the metal piece that's black with the curly Q thing. Unscrew it, put it in the hole, screw it back together, and it creates a nice stand. That way, when your hot soldering iron has to go somewhere, you don't burn your table or burn yourself. You just slide it into the coil. It'll stay there nice and safe, and then you pull it out. So assemble your soldering iron stand. After you assemble your soldering iron stand, you'll find a little um, uh, SpongeBob. You'll find a little sponge. That's it. And in your kit, take the sponge and moisten it. Put a little bit of water on the sponge, and then put the sponge there in the little divot. And we'll talk about why we do that in just a few minutes once we get soldering iron. Next, take your soldering. Excuse me. Next, take your soldering iron and put it in your holder. Turn the little knob here to just a little past the green, maybe over here into the second red, just a little warmer than middle, and put it in the soldering iron stand, plug it in, and flip the switch to on. Now, the soldering iron will take 3 to 5 minutes to heat up. Just plug it in, let it sit there while we get everything else out. Now, unpack your solder. Now, the solder that we bought is a really fine tin and silver solder. The kit included its own solder, and if you wish to use the kit solder, that's great, but I like the solder that we get better, in my humble opinion. So just get your solder out, get your snips out, and then get the kit out. Now, once you open up the kit, you'll find the board, the circuit board here. You'll find an electrolytic capacitor here. You'll find a capacitor marked 104 here. You'll find two little tiny capacitors that are 30 picofarads, and they're marked with little 30s. There are two of those. You'll find two resistors. You'll find a transistor. There are a couple of switches. There's a power connector. There's a crystal. There's a piezoelectric little sounder like speaker thing. There's a chip, an integrated socket, a socket that the integrated circuit goes into. There's a bar of resistors, and this is kind of a resistor bar that all is in one. So it's actually like 8 resistors all built into one. And then there is your 7-segment LED device. And then there's your circuit board that we're all going to solder it to. So lay all of these out, sort them out, make sure you know where everything is, and then we'll get started doing our assembly because by now the soldering iron is nice and warm. So take the 7-segment LED and line the little pins up and slide it into your circuit board from the side you see me doing it. Notice that there are these little dots along the bottom. Be sure they point to the middle of things and don't put this in upside down or put it in on the back side. So let's flip it over and see what that looks like from the back. And you can see the pins have slid in. You may need to jostle a little bit, twist them a little bit. Be careful, they're really fragile, but you can bend them a few millimeters if you need. Once you do that, it's now time to start soldering. There are lots of YouTube videos on soldering, but I firmly believe there's only one way to solder, and that would be to uh, take the soldering iron, like I've got my pencil here, and take the solder, and you put the soldering iron on the little wire coming up out of the board. Put the soldering iron on the little wire coming up out of the board, and it can touch the board and the wire. And then you take your solder and you touch it here at the tip of the pen, at the tip of the soldering iron, and push maybe a millimeter or two of solder, just the tiniest bit. It just takes a couple of millimeters, just to do, and then take it all away. And if it looks like this, if it looks like this, and has grown up the wire and kind of looks like this, then you probably have a good connection. You want to make sure it goes all the way around and it's nice and smooth. And if it kind of glistens and doesn't look kind of lopsided, or if then it's great. If you see a little hole, then go back and do it again. You should only keep contact with the wire and the board for just a few seconds. This is put it here, one, two, take it away. The joint should be perfect. Don't put too much solder, because if you get a glob like this, you're not going to be happy. Um, just as little as possible, just to get this kind of shape happening so that you can see the solder on the board and the solder nicely on the wire. So now that we've soldered our first few pins, let me shrink myself here. You can see that here I've soldered along through here and have the first few pins ready to go. So I do all of those pins on the 7-segment LED, and then I just snip off the little wires because they were a little too tall. So I just snipped them off right above where the solder is. You don't have to snip it all the way down to the board, but just get it down just a little bit sticking up. That's great. So I just snipped the board nice and clean, snipped all those off, because if I leave them all standing up and do all the rest of the soldering, they'll all be in the way. So let's not do. And you can see there I've got everything snipped off. Everything looks good. So now I'm going to put in the resistor pack. Now the resistor pack has got a little dot on it, and that little dot needs to go to this side. So you'll see the dot and the writing facing you as you hold it. So put it in, make sure you put it in. And then what I do is I get a little piece of tape, electrical tape if you have some black tape, or if you've got a little bit of duct tape, or you've got a piece of scotch tape or something. But take a little tape and tape it down, kind of like seat belt it down so that it doesn't go anywhere, so that it doesn't fall out when you turn the board upside down, do the solder. So you'll see me taping just about everything down, and if I don't mention it, I probably did anyway. So I tape it down just so that it doesn't go anywhere, and then I flip it over and solder it, and then take the tape off, and there you go. I then am now putting the socket on. The socket is the next step. Now the socket has got a little notch in it, and the socket notch goes over here. You'll see that this pin here is marked on as pin 1 on the board itself, and the little notch goes it on the side where pin 1 is. So be sure you put the little notch over here. And now let's tape it down, give it its seat belt, flip it over, and solder it in. Now we're going to insert the two switches, and the two switches go here and here on the board, just under the socket. Now the switches don't tell you which direction they go, but you kind of see the little feet in the picture. Be sure that the little feet kind of hook like that and go straight down. So you'll see that one switch goes here, one switch goes here. Let's see. There's you can see the switch inserted. You can see how its feet kind of do this. So be sure your switch's feet are turned the right direction and not the other way, but turned kind of like that. You may have to jiggle the feet, spread them out a little bit. It's a little tricky getting everything in the holes, but once it goes in the hole, those little feet will kind of grab the hole and it won't fall out. And put both of those switches in and solder them down. Now, after a little while, with me, and you probably have already seen this, your soldering iron tip starts to get a little grody, starts to get a little dirty. Maybe there's a little solder, a little extra solder on the tip, or it's got a little blackness. Well, that's residue from the solder. That's residue from little bits of plastic or a little bit of dirt, and that's perfectly normal. That's why we have the wet sponge. Take the soldering iron tip and just groom it on the wet sponge. Just push it down and groom it. You don't push real hard. And you'll see some of that grodiness come off. You'll see little bits of solder come off onto the sponge. And when you look at your soldering iron tip, it will be nice and silvery and pretty. You may have to groom your tip several times during this operation. But by this point, you'll for sure be needing to. That's why I took a picture of it, because that's what oh, wait a minute, I just groomed my tip. I need to tell them to do. So be sure to use that wet sponge. That's why we did it originally, was so you could use it to groom your soldering iron tip. And you see little bits of grodiness left here behind where we were. Um, I now at the power connector, that little box, that little square, little square thing, and that's the hole where the plug goes. So be sure that the plug faces out of the board. Put it on, turn the board over. You need to tape it down, solder it down. So you'll have the three connections there. The next is I put in was the piezo element, which is the little buzzer set, the little buzzer thing that makes the buzzer. And it has a positive and a negative side. There's a right way to put this in and a wrong way to put this in. There's a little paper piece of plastic, little sticker on top that marks which end is plus. Be sure that the wire on this side goes into the little hole here that has the plus. Enough. Just put it in, tape it down if you need to, turn it over, solder. Okay. Um, Now, there are 4 capacitors in this kit. 2 of the capacitors are 30 picofarads, and they're little ceramic discs that are these little beigey color, and they have the little number 30 on them. So the first 2 capacitors I want you to pick up are the 30 picofarad capacitors, and they're marked with little 30s. And they go here on both sides of the crystal. Down here on the bottom, one goes here and one goes here, and you can see that the circuit board even says capacitor 2 is a 30p, and you see that's got a little 30p there, so you know which one goes there. Be sure the right capacitor goes in the right place. You just slide them through the hole. Again, you're probably going to put a piece of tape on them and tape them down so they don't run off. Flip the board over and you can see the little wires are sticking up in the correct holes here and here and here and here. And I'm just going to take the iron and go doot, 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 and solder those little puppies right down. So now that I've done that, I've flipped the board back over, and over here next to the piezo element, the next capacitor goes. That's a little ceramic capacitor that's got a 104 on it. Um, it's I don't know what it stands for, but it's a 104. So, and you'll see on the board that it'll say 104. So slide it in the little holes there, tape it down, flip the board over, and put some solder on it, and clip its leads down so that it's all nice and pretty. The fourth capacitor is what's called an electrolytic capacitor, which is the little can. And the can has got a direction. It's got a plus and a minus side, and if you put the can in backwards, it won't work. So be very careful. The can that they sent me had a sign that said a side that had minuses on it. See how there are minuses here on the side of it. What I do, I just look at the circuit, and the little board said, well, there's a plus side and there's a minus side. So make sure the wire on the minus side goes to the minus hole, the wire on the plus side goes to the plus hole. Turn it over, solder it down. Easy enough. Clip it off when you're done. Keep your circuit looking great. Now, it's time to start adding the resistors. And the two resistors that we're adding, they're the same size. They have the same ohms resistance. I don't remember what the resistance was on those two resistors. Well, where are they? They're 1K, they're 1000 ohm resistors. And the little color code bands on them will tell you if you have a little chart telling you what those little color codes mean. But you don't need to worry about it because they're both the same. Take them and bend them, take them off the little paper they're on, and bend them looking like this into a U. You don't it doesn't take any force, just barely, just nice and easy. So bend them, and then we'll slide them onto the circuit board here and here. See the two spots where the resistor goes, here and here. And polarity direction doesn't matter. They can go this way or that way. It doesn't matter. Just as long as they get in there and their legs are nice and in the holes. You turn it, look at it, your board. You can see how the legs are really long and they're all kind of dangly. I put a piece of tape on top, hold them down, flip it over, solder, and then I clip the legs off nice and short so that they don't get in my way. The next thing that we're going to add is the crystal. Now the crystal is a little, it's actually a crystal that vibrates, and that's what keeps time. That's what tells the chip how to keep time. Is the crystal is just sitting there vibrating, and because it's vibrating on a cycle, it's always doing the same thing. Um, we know that well, it'll tell everybody, it'll keep everybody in sync. It'll keep the clock. The crystal is a 12 megahertz crystal. So that crystal is generating a signal that's 12 megahertz. And that's what tells the clock chip how to keep time. So 12 megahertz, we put the crystal in its hole, tape it down, flip it over, solder, clip its leads. Okay, yep. And then the last component we're going to put in, and we should have all of our components that we stacked out ready to go. Last component should be the transistor. Now the transistor is it's in a little plastic box, little plastic, and you can just see the shape on the circuit board. Just slide its three little legs in the three little holes. May have to spread them out a little bit, but just slide the three little legs and three little holes, slide it down, put a piece of tape on, flip it over, solder it, clip the lid, So by this point, you've probably got pretty good at soldering, and you can see here's what my finished board looks like. You can see all of my solder joints are pretty even. They're pretty good. Um, if you put too much solder on a joint, that joint can jump over to the to the joint next to it. If that happens, you can use your iron and usually go between them and kind of heat the solder up, and you can make it sometimes get a gap. There is a desoldering tool in your kit, in your toolkit. I really I don't use a desoldering tool very often. And when I do, I don't use that type. I use something called a desoldering iron, which is a really dangerous thing, and I always burn myself with it. It's a pain to use, but it does things that the little thing we're using, the little sucker tool that we have. won't do, but you can find all kinds of YouTube videos on how to use that little sucker tool. I'm not going to go into the details of that. I'm just going to let you go and do some of that research on your own if you find you screw up, which you probably will. But again, this little kit should be fun, and it should take you 30 minutes to an hour to get to this point. And let's see what happens. So I've got my kit, and I turn it over. Now we're done soldering, so I've turned my soldering iron off. I've put the soldering iron off to the side. Now it's hot, so don't put it up yet. Got to let it wait 10 or 15 minutes until it cools down after you unplug it. Put your little switches off, unplug it, set it off to the side. I've picked up all those little bits of wire that are scattered all over everywhere because I want to make sure I got them all and don't short anything out. And now it's time for me to put the integrated circuit, the chip, into the circuit board that we have just created. Now, the chip has got a little notch here. See that little notch on this end of the chip? This end doesn't have the notch and that end does. Well, the notch here goes along with the notch here, goes along with pin 1 here. So the chip, if you put the chip in the wrong direction, it won't work. Possibly fry it. So be sure to put the chip in the right direction. But as long as you got your notches lined up, everything is groovy. So grab the chip. Now, the pins may have gotten a little wonky and might not be totally straight, or they might be doing this, or they might be doing this, or they might be doing this or this, but I hope they're not doing this or this. But you can take the pins and you can just very gently with your fingers kind of straighten them out. They're fragile. So don't try to force it. Just be gentle with them and get them all lined up nice and pretty. And once you do, you can set the chip directly on top of the socket, and all of the pins should kind of go here in the hole. You should just see that all of the pins are lined up here on the outside of the connector, not outside the socket, but in the socket, and all lined up so that when you gently push on the chip, once you gently push on it, you'll feel it just kind of goes and just kind of set itself down, and it'll get all groovy and be really happy. And none of the pins will go off because if you see a pin go off, stick it off to the side, you're gonna need to pull the chip out, and that's kind of you got to be really careful to pry it out from both ends, nice and easy, or you'll bend the little pins. But if you're careful, getting that chip in and just gently, I mean, you may have to put a little bit of pressure, but not more than just a few ounces of pressure, and that chip should just go right down in the little socket, making noises, but it kind of makes a little noise when it goes in, and it just feels good. And you'll feel it. You'll be like, oh yeah, that's right. And look at the once you put all of the pins, once you put the chip in the socket, you'll be able to look at the board and you'll be able to look right in through along each one of the pins and see the little pin is down in the little socket the way it should be. And you'll look over here and you'll see the little pins are in the little socket. And darn, if we haven't completely built us a clock. Look at this. It's got an integrated circuit. It's got a couple of switches. It's got a power connector, a piezo element. It's got a transistor. It's got 4 capacitors, a 104, which is a 1.4 microfarad. 104 is a 1.4 microfarad, 2 30 picofarads. And now that we know what 1.0, no, point 0.1, it's 100 nanofarads. It's zero point 0.1 microfarad, zero point 0.1 microfarad. So that's what a 104 stands for. So our 104 is here, our little 30s are here, our electrolytic capacitor is here, our resistors are in place, our transistors in place, our LED display is all groovy. Make sure you clean up your workspace. There's nothing laying around, no wires, nothing stray. And if you did everything right, you can plug the power connector in and plug it into a little USB thingy. like your little cell phone charger or one of those kind of little wall wart kind of things that you've got a USB port. Um, but plug it into your little USB port and it should light up and say 1259. If you let it sit for a few seconds, it'll go to 1300, which would be 1 p.m. military time, and it'll start beeping at you because there's an alarm set for 1300 and by default. So your alarm clock now works. So you just go through the instructions here of how to set the clock, hitting the button 1 and button 2 and setting the clock. Your clock should be rock and roll. And when I finished putting mine together, it was 23:38 or 11:38 at night when I put this video together. So we've assembled the clock. We've done the whole thing from start to finish. Now, troubleshooting. There will be a little bit of troubleshooting for some of you. Be sure that you don't have any cold solder joints. And a cold solder joint is where the wire comes up, but the solder doesn't do this all the way around. The solder kind of will blob like this. That's what we call a cold solder joint, or the solder won't fully fill the hole, and you'll see some of the hole still there, but the wire is coming through the hole, and there's some solder, but it's not fully silver and bright and and that shape. So go back through and make sure all of your solder joints are good. I'm an old guy, and I usually have a magnifying glass on my desk, on my workbench while I'm soldering, just to make sure that I can see each and every one of those solder joints. And after I do 3 or 4 solder joints, I pull out my magnifying glass and just check them all, make sure they're all good, and go through and check each and every one of them with a magnifying glass. Um, I didn't get you magnifying glasses because figured you were young and didn't need them. But if you do, go find a magnifying glass around the house and uh, check your solder joints. Make sure you don't have any solder joints that bridge. You don't have any bridge joints. You don't have any joints that touch each other. And if you do, take your warm soldering iron and kind of run it between. You'll see the bridge joint coming apart. Make sure all the parts are in the right place. If you've got to unsolder something and solder it back, follow the directions you find on YouTube on how to use that desoldering tool, and you can do it. I know you can do it. I started soldering when I was in middle school. I had no idea what I was doing. I had a kit, and I just did it. I messed up. I made mistakes. It took me a lot of time to debug and try to find what was wrong, but I did it and I can do it, and I know you can do it. And at the end of this, you're going to have a clock. It's going to work. Keep it plugged in. It'll keep time. Now, it doesn't have a battery on it, so when it gets unplugged, it'll lose its time, but it's yours and you did it and you built it. And with your 3D printer, hopefully some of you doing the 3D thing, maybe you'll build you a case for it. Wouldn't that be kind of fun? So there's your 3D, there's your clock, and there's building the clock set. This video isn't the best one I've ever done, but um, it should get you through this clock assembly. Again, I'm Dr. Renault, Dr. James Renault from Shawnee State University. This presentation is copyright 2020 by me, James M. Renault. All rights are reserved. Um, and I hope you have a great time. You can also contact me at jrenault@shawnee.edu, JRENEAU at shawnee.edu. Um, and I wish you the best of luck. And if you have problems, contact me through the contact information that I've given you in class. Have a great night. Good luck.